All right, today we are on pages 13 and 14. So we are going to actually talk about how to dilate figures on the coordinate plane. So make sure you have your notes out and you're writing this down. So to dilate a figure on the coordinate plane, we are going to multiply the x and y values of each ordered pair by our scale factor. So yesterday we talked about what a scale factor was and how it makes something larger or smaller, and that's how we make things larger or smaller on a coordinate plane. So if the scale factor is larger than 1, it enlarges the picture, or it makes it bigger. If it's smaller than 1, it will reduce the size. It'll make it smaller. Okay. Then finally, we talked about this yesterday. When a dilation has occurred, when we've made something bigger or smaller, we can find the scale factor by choosing corresponding sides, which is just matching sides. Okay, and setting up the ratio. So the ratio would be the new compared to the original, or the image compared to the pre-image, or, I just like to use the after compared to the before. And that will tell you again what your scale factor is. Again, we did that yesterday. Okay, so we have this rectangle and we are going to dilate it by a scale factor of 1/3. Okay, first off, 1/3, just knowing that number is smaller than 1, we should hopefully know that we are making it smaller. So we are going to be reducing the size. Okay, so we are going to first write the coordinates of the rectangle A, B, C, D. Okay, so A, the ordered pair is -6, 3. B is 6, 3. C is 6, -3. And D is at -6, -3. Okay, so we are going to dilate this by a factor of 1/3. So what we're going to do is we are going to multiply everything by this scale factor. So we're going to multiply the x coordinate by 1/3 and then multiply the y coordinate by 1/3 as well. So we are going to be needing our calculators if we don't feel confident with fractions. So we're going to do -6 times 1/3, and -6 times 1/3 is -2. Then we're going to do 6 times 1/3, or excuse me, 3 times 1/3, which is 1. So our new dilated point will be at -2, 1. So -2, 1. All right. Now we're going to do the same thing for B, C, and D. Okay, B is at 6, 3, so B prime. 6 times 1/3 is 2. 3 times 1/3 is 1. So B prime is at 2, 1. Oopsie. Okay. C prime. 6 times 1/3 is 2. -3 times 1/3 is -1. So C prime is at 2, -1. Okay. Finally, you guys are going to do the last one. Okay, D prime will be at -2, -1. -2, -1. And then we connect the dots. We can tell it's obviously been reduced a lot. And the algebraic representation is what did we do to these numbers? All we did was multiply by 1/3. So algebraically, we multiplied the x coordinate by 1/3, and we multiplied the y coordinate by 1/3. And this is the algebraic representation, 1/3 x, comma, 1/3 y. All right, number 2 says, compare the ratios of the corresponding sides. So corresponding sides are just their matching sides. So I'm going to compare a B, and I'm going to compare that to its dilated side, A prime, B prime. So I'm going to count how long A to B is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And now I'm going to compare that to A prime, B prime. So 1, 2, 3, 4. Okay. if I compare these corresponding sides, and if I put again, the ratio is always the after to the before. So if I put a B prime over a B, this is 4 units long, and the after is 12 units long. If I were to simplify that, I get my scale factor. Whoa, crazy. Okay. Then it says, did the dilation change or preserve the orientation of the figure and the orientation of the vertices? So orientation of the figure is the way it's facing. Okay. Did I change the way it's facing, or does it look like it's facing the same direction? And I can just compare A, B and A prime, B prime. They're both facing up. So it preserved that statement. It kept it the same. Okay. Then the orientation of the vertices, which are the order of the points. So if I go in order A, B, C, D. Okay. And if I look at the primes, again, going in the same order, it's also in the same order, A prime, B prime, C prime, D prime. It also preserved the orientation of the vertices. All right. So we're going to do a couple more problems. This one says to dilate it by a scale factor of 2. So we have E, F, G, H. Okay. So E is at -4, 2. F is at 4, 2. G is at 3, -1. And then H is at -3, -1. Okay, so this is probably the easiest transformation if you get the hang of it. All we have to do is multiply by our scale factor, which is 2. Okay. Okay, just making sure that we multiply everything by 2. So E prime will become -8, 4. Multiply -4 times 2 and 2 times 2. F prime will become 8, 4. G prime, multiplying everything by 2, would be 6, -2. And the last one, H prime, will become -6, -2. Okay, so then after I have those new ordered pairs, I can just plot them, -8, 4. So this is E prime. F prime is 8, 4. G prime is at 6, -2. H prime is at -6, -2. Okay, so then I just draw a pretty picture. Okay. Then the algebraic representation is we just took all these ordered pairs and we doubled it because that was the scale factor. So it would be 2x, 2y. All right, this one, it says to dilate by a scale factor of 3/2. So first, it's just good to know if this is going to enlarge it or reduce it. Okay, since this number 3/2 is larger than 1, it hopefully, if we do it right, it should enlarge it. Okay, so we're going to write the 3 vertices, J, K, I. Okay. J is at 4, -2. K is at -4, -2. And I is at 0, 4. Okay, so you guys are going to try writing these ordered pairs. Okay, so we're going to multiply by the scale factor. Okay, so 4 times 3/2 would be 6. -2 times 3/2 would be -3. K, -4 times 3/2 would be -6. -2 times 3/2 would be -3. 0 times 3/2 is 0. And then 4 times 3/2 is 6. Okay, so we plot those points. J would be right here. K would be there, and then I would be right there. Okay. Then try to write the algebraic representation. All right, the last couple of problems are what we'll be practicing because it's taking a little bit more complex. It says to find the scale factor, okay? So what I'm gonna do is I'm gonna find corresponding parts, okay? I'm gonna find, again, I don't wanna do a diagonal one because we don't really know how long that is, so I'm gonna use the bottom one. So I'm gonna use M to N, and I'm gonna find its corresponding part, which is its matching part, M prime to N prime. Okay, so I'm going to do after over before. Okay, if I think about after, I'm talking about the primes, so I need to think about M to N prime. And then the before will just be M to N. Okay, so I'm just going to count. The after is 1, 2, 3, 4, 5 long. And the before is 1, 2, 3, 4 long. Okay. I can't really simplify that. We could make it a decimal, but there's no point really. This scale factor is 5/4. All right, now I'm gonna have you guys try this scale factor. Okay, I need to do the after. So I'm gonna do P prime to R prime, 1, 2, 3. Okay. And then I'm gonna compare that to its before, which is PR. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then at 3 to 9, I can simplify to 1/3. So the scale factor is 1/3. All right. Then this one is the last problem where I give you 2 points. I give the original point and the dilated point, and we have to find the scale factor. So we just have to make sure we're using corresponding parts, and we'll check with the other one. So I'm going to use the x coordinates, okay? So this is the after, and this is the before, so I'm just gonna write after over before on the bottom so we can always notice what we're doing, okay? So the after x coordinate is 6, the before coordinate is 9, which can be simplified to 2/3. So if we're right, if we check our y coordinates, we should hopefully get the same thing. So we're gonna check the same thing. Our y, compare our after to our before, and 8, that would be 4/6, which is also equivalent to 2/3. So our scale factor is 2/3. All right. I'm going to have you guys do number 9, so we'll do number 10 together. Okay. So we're going to check. This is our before, our u to our u prime. So I'm going to compare -9 to -1, which is equivalent to 9. So this is a scale factor of 9. Okay, this is really hard to use to check because 0 to 0, whatever you multiply by 0 stays the same. So this is just our scale factor of 9. So we had to use the x coordinates to figure that out. All right, the final one you guys are going to try. All right, for this one, we have to use the after to the before. So we have 12 over 10. I'm going to simplify that to 6 over 5. Okay, so if we are right, we should also get 6 over 5 when we compare the other ones. So we have -18 to -15. Okay, I notice a negative, negative. A double negative is the same thing as a positive. I'm going to divide both of these by 3, and I also get 6 over 5. So our scale factor is 6/5. Okay, so for today, guys, there is adult math that you guys will practice as well.